Hi students, today we are discussing a discussion of behavior patterns. Already we've seen in third unit a discussion of structural design patterns, and coming to the fourth unit we will discuss fourth unit, fifth unit discussion of behavioral patterns. In behavioral patterns coming under 11 design patterns you need to study in previous classes. Okay, now we see the discussion of behavioral patterns. There are so many behavioral patterns we have discussed. That is encapsulating variation. The first one is encapsulating variation and objects as arguments, and you should communication be encapsulated or distributed. And finally we seen decoupling the senders and receivers, how the separation, how the decoupling in the sense separating the senders and receivers, how it will be. Okay, now today we are studying encapsulating variation. In the sense, it is one of the best theme of many behavioral patterns. You see in so many behavioral patterns. Here it is a main part. In the sense, it plays an important role in behavioral patterns. Whenever an aspect of a program change frequently, these patterns define an object. Okay, in the sense, whenever if you take some of these patterns, just we need to define an object that encapsulates that aspect. Okay, that encapsulating, in the sense encapsulating one unit. Okay, we want to binding one unit, that aspect, just we want to define an object whenever a program changes frequently. So these patterns define an object. These patterns define an object that should be encapsulated with that particular aspect. So here the other parts of the program can collaborate with the object whenever they depend on that aspect. Whenever they depend on that particular aspect of a program, these other parts of the program can collaborate with that particular object. Okay, whenever we depend on that aspect of a program. So simply what we say, these patterns just usually define an abstract class. Okay, an abstract class is a class that contains what that describes the encapsulating object, So here, what does the pattern derives here? In the sense, the pattern derives its name from that particular object. The object, in the sense, this theme mainly runs through other kinds of pattern. Okay, the other kinds of a pattern, simply we say. Okay, so for example, let us see here strategy design pattern, state design pattern, mediator design pattern, and finally iterator design pattern. Okay, what is the main intent of a strategy design pattern? In the sense, a strategy design pattern is an object that encapsulates with an algorithm. Okay, one strategy object. Strategy, it plays an important role in software design patterns. Especially at runtime, we change. Okay, a strategy object encapsulates an algorithm. And coming to the state, it performs an action. Just whatever a state object we need to define an object, just it encapsulates a state dependent behavior. It encapsulates a state dependent behavior. Okay, and coming to this mediator, the name itself says mediator between objects. Okay, a mediator object encapsulates the protocol. A mediator object encapsulates the protocol between objects. And coming to the iterator object, what that iterator object do? An iterator object encapsulates the way how can you access and how can you walk or traverse the components of an aggregate object. Listen carefully. An iterator object, it encapsulates the way how you can access and how you can traverse those components of an aggregate object. Here what I mentioned in the sense, these patterns describes what is the main aspect of a program. There are certainly to change. So here most of the patterns have two kinds of objects. How many? Two kinds of object. The first one is the new objects. What that new objects do? That encapsulates the aspect of a program, and the existing objects. Existing objects, that use of new ones. Okay, so finally, usually whatever the functionality of new object would be an integral part of the existing object. Okay, fine. What we can do, what is the use, what would use here? Usually the functionality of new objects would be an integral part of the existing objects, wherever if we have to be supposed to use. For example, let us take a code for strategy design pattern. It would probably design into the strategies context. Whatever the strategy context, the strategy object encapsulates an algorithm. Okay, so now we see the code for strategy design pattern, and next the code for a state design pattern. What the state object encapsulates with you? A state dependent behavior. Certain operations it will be performed. A state design pattern, it would be implemented directly. It would be implement directly in the state context. Okay, but not all object behavioral patterns. Understand? The state design pattern, it would be implemented directly in the state context, but not all object behavioral design patterns. Okay, now here we look at this, the functionality. A functionality, it look like this. Okay, for example, we see now a chain of responsibility. What the chain of responsibility do you? The chain of responsibility, it deals with arbitrary number of objects. What ma? It deals with arbitrary number of objects. That means a chain. So here a chain, all of which it may already exist in the system software. The main intent of a chain of responsibility just illustrates you the difference in behavioral design pattern. Not you can define the static communication, how the relationship between those classes and objects. The main, it prescribes the chain of responsibility, how the communication between an open-ended number of objects. So finally, whatever the other patterns involve, those objects, listen carefully, those objects that are passed as an arguments. Okay, those objects that are passed around as arguments. This is the concept of encapsulating variation. How we can variate the encapsulating. It is a very important, it plays an important role in software design patterns. It is a theme of many behavioral patterns. Whenever an aspect of that particular program, it will changes frequently. Okay, and coming to the next concept in that discussion of behavioral patterns, objects as arguments. Okay, objects as arguments. What that mean? Objects as arguments, in the sense we've seen several patterns. Let us introduce an object that always used as an argument. Yes, exactly. We need supposed to introduce an object that will always used as an argument. So here one of these patterns is a visitor pattern. Here objects as argument we seen one of these is visitor design pattern. Okay, visitor visit something. Okay, a visitor visits something like an object, a visitor object. Let us take a visitor object is the argument to a polymorphic accept operations on the object on the object it visits. How it will be? So here the visitor is never considered the visitor is never considered a part of those objects. So even though here the conventional alternatives to this particular pattern is to distribute how the visitor code across the object structure classes. In the sense, listen carefully, a visitor object it's one of the argument one of the argument to a polymorphic accept operations, and one or more forms we supposed to accept that particular operation on the object it visits. So here the visitor is never considered a part of these objects, even though the conventional alternatives to this particular pattern is to distributor. The distributor distributes something like the pattern is to distribute a visitor code. The pattern is to distribute a visitor code across the object structure classes. Across the object, across means from one place to another, the object structure classes, how those patterns is to distribute. Okay. And coming to this, other patterns define objects, and remaining patterns define those objects that acts as magic tokens. Okay, to see, to be passed around and invoked at a later time. So here we need to study both command design pattern and memento design pattern. This command and memento, it fall into this category. First of all, we need to study a command. In command, we seen the tokens. The token represents a request. First of all, the token represents a request. In coming to the memento design pattern, it represents the internal state of an object. It represents the internal state of a particular object at a particular time. So in both cases, we seen the token can have a complex internal representation. The token can have a complex internal representation, but the client is never aware of it. Here the client is never aware of this. Okay, so but even here there are so many differences among polymorphism is important. Polymorphism is important concept in the command pattern, because here we need to executing the command objects. The command objects, it is a polymorphic accept operation. In contrast, we seen the memento interfaces, how the memento interface is so narrow that a memento design pattern can only be passed a value. The memento design pattern can only be passed as a value. So it should be very likely to present no polymorphic operations to all of its clients. Okay, to all to its clients. Exactly what I say, a command object is a polymorphic accept operation, and coming to the memento interface is very narrow, that a memento design pattern can only passed as a value, so we would present no polymorphic operations at all to its clients. Okay, now we see the third one, that is nothing but should communication be encapsulated or distributed. In the sense, now we see the third concept is very easiest concept. Should the communication between those objects, how it should be encapsulated or distributed. Now we see here a mediator design pattern and observer design pattern. These two design patterns are very competing patterns. The difference between them, the observer and design and mediator design pattern, now we see the observer distributes a communication. The observer distributes a communication by introducing observer and subject objects wherever as a mediator object encapsulates the communication between other objects. It is the main intent of mediator and observer design pattern. And coming to this observer design pattern, how it should communication be distributed, in the sense in the observer, now let us see, in the observer design pattern there is no single object. Listen carefully, there is no single object that encapsulates a constraint, in the sense condition. Instead of the observer design pattern, and the subject must cooperate to maintain the condition. Okay, subject must cooperate and we supposed to maintain the condition. Here the communication, those patterns, or just we need to determine how the way we can access observers and subjects are interconnected, how the way observers and subjects are interconnected. Now we see a single subject usually has many observers. Listen carefully, ma. If you have single subject, that usually has many observers, and sometimes the observer and sometimes we seen the observer of one object as a subject of another observer. Okay, now coming to the mediator design pattern, it should be centralizes rather than distributes. Okay, the mediator pattern centralizes rather than distributed. Okay, so it places the responsibility, it places the responsibility for maintaining and manipulating a condition squarely in the mediator section. So we have to be find here, it should be very easier to make it very reusable also. So here finally I say observer and subjects, then to make reusable mediators, observers and subjects, then to make reusable mediators. So finally the observer design pattern promotes partitioning. The observer design pattern promotes partitioning, and we seen loose coupling. Loose coupling means it should be easy to access and it should be easy to make it loose coupling between observer and subject. So mainly it leads a finer grained classes that are more apt to be reused. In the sense, again and again we have to be modified and we have to be reused the observer and subjects. Here that leads to finer grained classes that should be very apt to that reused purpose. Okay, on the other hand, it should be very easier to understand the flow of communication in mediator than in observer. Okay, so the observer and subjects are usually connected after they are created. So it is very hard to see how they are connected later in that particular program. If you know how the observer design pattern, you understand that the way how the observers and subjects are connected is very important theme in software design pattern. And if you also know what connections to look for that, okay, what connections to look for, so here directly that observer introduces, it will make sure that it make a system a very harder to understand. Okay, observer introduce will still make a system harder to understand. Okay, finally we see the observer design pattern. In Smalltalk MVC we seen the observer design pattern. It can be parameterized with messages, how to access those messages, the subject content also. Here finally I say they are very reusable than they are in advanced data structures. So finally this makes you the observer more attractive than mediator in Smalltalk. In Smalltalk language. So the Smalltalk programmer will oftenly use the observer design pattern, whereas a C++ a programmer would use mediator design pattern. Okay, this is the concept of how should communication be encapsulated or distributed. Okay, finally what I say, observers in small talk can be parameterized with messages how to access the subject stage, and so they are even more reusable than they are in C++. So this makes observer more attractive than a mediator in a small talk. So finally, hence a small talk programmer will oftenly use observer, whereas in C++ programmer would use mediator design pattern. Okay. In further video, we will discuss decoupling senders and receivers. Thank you.